Hi there. Okay, so we're going to do a quick demonstration with Newton's Cradle. Sorry we didn't fit this into class, but this isn't that bad either. Okay, so this is an example of Newton's Cradle. This is what it looks like. It's also an example on the front of your physics booklet number 5, except instead of using metal spheres, it uses children. Okay, not super nice. So the first thing I'd like you to do is draw a little picture of the apparatus, and let's draw it from the side view like this. Okay. Okay. So this whole activity here is just about guessing and predicting, and I'm going to number these spheres like so, just to make it a little bit easier for us to describe what's happening. Okay. So number 2 says pull one sphere away from equilibrium and release. So I'm going to pull number 5. What do you think is going to happen? Write down your guess, and then when you're ready, hit continue. So I'm pulling number 5. Okay. And notice how 5 transfers its momentum to 4, transfers it to 3, transfers it to 2, transfers it to 1, and because there's nothing outside or after number 1 is able to freely swing out and then come back, and then it repeats that process. Okay. Number 3, pull away 2 spheres from equilibrium and release. What do you think is going to happen? Okay, so I'm going to pull away number 4 and number 5. Okay, what do you write down your guess first? Which ones or what will happen to the movement? Okay, here we go. Okay, so I can show you again. Okay, so as we saw, 4 and 5 transferred their momentum to 3, 4, transferred it to 2, 3, and then as a result, they transferred it to 1, 2, and because nothing comes after 1 and 2 were then able to move freely and then come back, and they just continue to transfer back and forth. Okay, and number 3 really looks like it's never moving, which I always find very interesting. Okay, number 4 says pull one sphere away from each side and release them at the same time. Again, I'm going to pull 1 and 5 away, and you tell me what's going to happen. So predict first and then hit continue. Okay, not bad. So what's actually going on here? Well, it's not that 5 is bouncing off of 4 and then bouncing away. What it's doing is 5 is transferring its momentum to 4, which is transferring it to 3, which is transferring it to 2, which is transferring it to 1, and then 1 moves, but at the exact same time, 1 is transferring it to 2, to 3, to 4, to 5, and then 5 moves. So although it looks like 1 and 5 are just bouncing off of 2 and 4, they're actually both transferring their momentum in the opposite direction. Okay. Number 5 says pull 3 spheres away and release. So I'm going to pull 3, 4, and 5, make your prediction, and then let's see what happened. Okay, that was pretty good. I'll do it once more. Oh, maybe I should just use my finger. Okay, so at the very beginning, if you guessed that 3, 4, 5 would transfer to 4, 3, 2, which would then transfer to 3, 2, 1, okay? And it looks like you always have two balls that are staying, or 2 spheres that are staying still. So if we go like this and try to see, so it looks like we have 1, 2, and then 4, 5 that are stable. Okay, and this transfer of momentum is just happening very quickly. Okay, right on. And that's it. That's how Newton's Cradle works. Thank you.